Hi, hello, and welcome back to Science as Process and Perspective. In last lecture, we talked about how scientific knowledge is a social construct, a cultural construct in some way, how it's history dependent on the context, the social, historical, the political context that it's in, the sort of scientific community that is postulating it. And we started sort of thinking about how that connects to realism. How is that not a sort of an opposition to a realist point of view? I was saying the real opposition is between objectivist realism and constructivism. You can still be a realist and believe that scientific knowledge is a social construct. How does that work? That's going to be the topic of this lecture. And I have questions again, but they're the same questions for once as we had last time, because this is a central and very complex issue. In particular, we're going to focus on the last two questions here. If scientific knowledge is a social cultural construct, and I think we have to accept that, can it still refer to an objective reality? If so, how does it do that? Those are tricky questions. So let's dive right into this topic. And so what I ended with last time is that it's really important for science to have a diversity of perspective that are colored by those individual experiences that we bring in, to how we ask questions, what kind of questions we ask, what kind of approaches we choose to answer those questions, and what kind of answers, what kind of explanations we accept as valid. I would say those are really important aspects of the practice, of the activity of doing science, that are sorely neglected in both positivist and Popper's falsificationist accounts, which are trying to sort of either rationalize these activities. In the case of positivism, it's just pointing at a bunch of observations, and scientific theories summarize those observations. That doesn't work. Or sort of, in Popper's case, denying the importance of this sort of inductive way of knowing, saying it doesn't matter where your hypotheses come from. It just matters that you can falsify them. And if you can't falsify them, they're not really valid scientific hypotheses. This is an oversimplified view. And in particular, it is neglecting the way we actually do bring forth hypotheses. We do ask questions in science. And so what we're going to do today, what I'm going to tell you, is based on an absolutely wonderful, wonderful, wonderful book by American philosopher Bill Wimsatt, which is called Re-Engineering Philosophy for Limited Beings. He's the proponent of something called multi-perspectival realism in this book. It's a difficult book to read. It's very sort of complex. The arguments are complex, very detailed, sticks to a lot of empirical evidence, and it's a complicated theory for a complex world, I would say. So it's a very interesting theory, but it's a hard read. So let me try and sort of crystallize, highlight a few of the major insights. I hope I will not oversimplify Wimsatt's wonderfully complex ideas too much in this context. And the central context here, again, is this idea of a perspective. We went a little bit into this. I told you about Ron Geary's distinction between a perspective in sort of common parlance, just being an opinion that someone could hold, different opinions on something, and a sort of a scientific perspective, which is a particular way of looking at a scientific problem. And Wimsatt refines this idea of a perspective and how it relates to reality in this wonderful book. So the subtitle is Piecewise Approximations to Reality. And you see this Archambaldi sort of cover here represents these sort of different local sort of models, maybe, that make up a bigger picture, but in a sort of a very sort of weird way. Okay, it's sort of a metaphor for how scientific knowledge is constructed. And Wimsatt calls this a theory of practice. Again, so we're turning back, and that's very important. That's a topic that will stretch over multiple lectures now. We're turning back from what historically is called the linguistic term in philosophy, both analytical philosophy and later, a little bit later, also continental philosophy, turned towards an obsession with language. And we're coming back, and Philip Kitcher, a philosopher, has called this the naturalist's return, a more sort of naturalist way, pragmatic way of looking at science, instead of a sort of an abstract way of analyzing propositional knowledge. So let's start with this sort of idea, you know, when you have an underdetermination, you have multiple sort of theories that could account for the observable phenomena, and they contain different kind of unobservables. How do we choose between those different theories if the world is underdetermining our our scientific theories? And of course, the most sort of famous way of doing this was first proposed in the Middle Ages by this monk, William of Occam. That's why it's called Occam's razor, or in Latin, lex parsimoniae. So this is a way of sort of choosing from different alternative explanations based, competing hypotheses based on the number of assumptions that underlie each one of them. So Occam is basically saying we should always choose the one with the fewest assumptions. And this is sort of a third way of reasoning in science, by the way. So we've encountered deductive reasoning, we've encountered inductive reasoning. This is called abductive reasoning, or also inference to the best explanation. So if you have several alternative explanations, you choose the one that is most plausible by some criterion. And if, you know, all of them are equally plausible, Occam's razor gives you an additional criterion. You choose the one that makes the fewest assumptions. Okay, so this is important because we want to avoid superfluous ontological apparatus, to put it in a very sort of philosophical term. So you do not want to multiply the entities that you consider to be real. You want to sort of deal with a minimal amount of entities. And this sort of, this is a doctrine, philosophical doctrine. It's not based on sort of any proof or empirical evidence that this is what you should do, but it's been really, really important as the foundation of reductionist science. Okay, you should bottom out and always choose the sort of lowest possible level of explanation with the fewest invented entities or hypotheses, the fewest assumptions, the fewest axioms. Okay, and that's how you get the best kind of knowledge. That sounds reasonable, but if you use it excessively, it becomes Occam's eraser. Okay, and it gets rid of a lot of interesting phenomena that science could be studying, and it ends up in Wimsatt's words in a sort of a desert ontology, a world in which there are very few things that you consider real. Think about theoretical physicists sort of going after the ultimate theory of everything. So they think these fundamental particles that they have and interactions of these particles, the fields, quantum mechanics, these are the only sort of real entities in the universe. And everything else is just what's called an epiphenomenon, sort of a derivative from those sort of fundamental entities and their interactions. Is this really how the world works? We can ask. So Willard von Ormenquine, again, he shows up over and over again. He's one of the most famous philosophers you probably never heard of, is associated with this type of ontology. But Wimsatt says, look, and this is a great quote that I'm just giving you to show, to give you a little impression of how his book, what experience you get from reading his book. He says, okay, what happened here actually historically is ontological genocide was practiced upon whole classes of upper level or derivative, in scare quotes, entities in the name of elegance. And we were secure in the belief that one strayed irremediably into the realm of conceptual confusion and possible error the further one got from ontic fundamentalism. Wow, what is that? Ontic fundamentalism is exactly what brings forth, it's Occam's razor, right? It's reductionism. It brings forth this desert ontology. It means that you only consider real what is fundamental okay, in your theories of physics. This is an interesting way of looking at the world because, as we established last time, these sort of theories of fundamental physics, they are social constructs. And the ultimate source of all of your knowledge is your personal experience. So these are constructs that we built out of some sort of collective experience historically, okay? And we cannot take those fundamental theories, foundationalist theories, as the basis of all of our knowledge. That's sort of taking, looking at everything sort of upside down, okay? They are the consequence of our, experience. They are not the basis of our experience. And so this is sort of what another philosopher, Alfred North Whitehead, called the fallacy of misplaced concreteness, where you take an abstract theory and you make it real, okay? So you're basically saying this is how the world really works. And because in those physical theories, only those really, really fundamental entities are real. That's the only thing that's actually real, okay? And that is wrong. That's what Wimsatt is saying here. So he says, basically, in this rich world that we live in, bottoming out, being an ultra-reductionist is actually a really bad idea, okay? And so he arrives at a very different view of the world than a theoretical physicist probably would. And he says, the world we live in is rich and is structured. It has these levels of organization that you can recognize, okay? So there's an atomic level, and we can distinguish that from a molecular level. So atomic level is determined by the laws of physics, the molecular level by the laws of chemistry. You get macromolecules, you get into biochemistry, cellular level, so that's biology, and then it gets, more and more complicated into the multicellular, biological, ecological, and social realm. You have multicellular organisms further to the right, larger organisms, and then you have the whole social, cultural, ecological domain. At the very right. So this is what we see. There are different phenomena in our world that happen at these different levels of organization. This is observable, okay? And so now in this wonderful drawing in Wimsatt's book that he drew himself, he says, okay, so now that we can distinguish these different levels of organization, we can sort of think about different ways in which they relate and how they are structured. So we could think about a world in which these levels are completely random, okay? So they pop up, they disappear again, and the reason there are these levels, it's completely random. But that's not how the world looks like to us. So if you have a model of the world that postulates that these levels are random, you must have made a wrong choice of variable of your model, basically. It could also be that the world is sort of uniform. It's a flat wave. There's no what he calls enification, no levels at all, okay? He calls this nature as an invertebrate. And so that's obviously also not what's happening. But then there are different ways of thinking about how these levels sort of interact and how they're structured. It could be that the lower levels are sort of fuzzy, they're not really well separated from each other, so he calls this entification is greater at higher levels, okay? So the levels become clear at higher organization, but it's also not really what's happening. Here is our world, okay, with a question mark though. So you have very clear separation of levels at fundamental levels like the atomic, molecular. So physics and chemistry deal with areas of reality that are very clearly separated into levels. While when we get into biology and then the social sciences, things get a lot more complicated. Enification is greater at lower levels. And so we get what he calls a dissipative wave. And he says this universe is pro-reductionist, okay? It's easy to be a reductionist because it's easier to describe these lower levels clearly than up here. And a lot of the entities in these higher levels, they overlap. They're not really clearly separatable. And so they're harder to deal with. And that's why physics is basically the science that chose all the easy problems. You wouldn't suspect that maybe from your high school experience with physics or from your experience as a physicist. But physics really chose all the easier problems, relatively speaking, than the biological or the social sort of sciences. Okay, so this is an extremely sort of rich picture of the world. It is structured, okay? So there is what complexity scientist and economist Herbert Simon has called near decomposability. He says everything is connected in the world, but some things are more connected than others. The world is a large matrix of interactions in which most of the entries are very close to zero, and in which, by ordering those entries according to their orders of magnitude, a distinct hierarchic structure can be discerned. So the structure is complicated if you go above the level of the very fundamental levels, but there is a structure that we can discern. How do we do this? Okay, how do we deal with complex systems? And so Wimsatt is saying what we need is a completely different attitude here. Okay, so we're talking about, remember his book is called Re-engineering Philosophy for Limited Beings. First of all, we're limited beings. This is not sort of an idealized science like the standard view of science, but it also takes serious the sort of phenomena we have. And our universe really looks more like a rainforest in this sense than a desert. Okay, so if you take those phenomena serious, you end up with this view where our world is not like a desert, but has the independent ontology of the tropical rainforest, multiple layers, but not clearly discernible. There is a structure, but it's very complex. This is a perspective seemingly more appropriate to modern cosmology, okay? So is not just focused on those special levels that can be clearly separated, but on the whole of reality. And it is also profoundly evolutionary, okay? So these sort of structures, they're constantly evolving and changing. This is the world we live in. Levels of organization are like ecosystems, he says. They evolve as a product of the evolutionary trajectories of the entities that compose it and provide selection forces that guide their evolution in turn. Everything is always changing, a more processual view. And he says levels define co-evolving niches for their composing entities. Okay, so this is a very dynamic, a complex view of the world, not the sort of view we're used to from theoretical physics and the sort of people who are looking for an ultimate theory of everything. This is the reductionist stream. This is not anti-reductionist either. It says, remember, so Wimsatt's worldview says, okay, this is a world we live in where reductionism is very powerful, but you have to sort of contextualize it by knowing that you live in this wonderfully complex rainforest sort of phenomena. And so to come back at this sort of image, why are different perspectives important for trustworthy scientific knowledge in such a world? So we're coming back to this question. If we assume now that we live in this complex and constantly changing world, how can we get trustworthy knowledge of such a world? And why are different perspectives important? Well, let's start by defining what Wimsatt means by perspective, because he has a slightly more sophisticated view of a perspective than Geary had as just a sort of a scientific sort of individual approach. Wimsatt said a perspective is an intriguingly quasi-subjective, or at least observer technique or technology relative cut on the phenomena characteristic of the system, which needn't be bound to given levels. So not only is this your view of a system, but it's a cut, it's something that is in a sense, you know, reflecting something real. Okay, it is a specific sort of view of reality. It is very similar to what Geary says with this different views on the statue of Hume. You know, the Hume statue is real, and we get different perspectives on it. So it's actually very similar to that, but a bit more sophisticated. And what's really important here is that these perspectives are always quasi-subjective. Okay, so they're dependent on you, the observer, the technique you're using at the moment, the technology you have at hand. Okay, so this is sort of a concept that unifies the idea of a realism. It's a perspective on the real world, but at the same time, it's completely history dependent on the social and political context that you're working in. And he says each system can be characterized by multiple perspectives. That's why he calls his philosophy multi-perspectival realism. Perspectives cannot be ordered hierarchically necessarily, and often do not add up to a complete picture of the system. Again, you don't get the complete picture of Hume's statue. And also, it's not, especially in the life sciences and the social sciences, easy to sort of order those perspectives into a clear order, although it gets easier as those lower levels of hierarchy are better separated from each other. Whether or not you have the right perspective will depend crucially on what your question or problem is. Again, opposite to objectivist realism. Who you are is actually important. Okay, the scientific method is still a method to make sure that your bias don't creep in. and your independence is assured, but your personal perspective determines what kind of questions you ask and what kind of explanations you want. It's crucially important what kind of perspective you will get. And this is just, you know, I may be flogging a dead horse here, but we never have and probably will never have certain and absolute knowledge. Okay, nothing is certain, not even that we will not have certain knowledge, but it's very unlikely. Okay, so perspectives are always sort of limited. So this is philosophy for limited beings. Now, how do we establish the trustworthiness of our perspectives? And here is a central concept, robustness, that Wimsatt introduces in his book. What is real or trustworthy? We need to secure the reliability of our conceptual structure so we don't drift into relativism. And what's very important, there is no privileged level of organization. So this idea of bottoming out, of going always to the lowest level, of eliminating all different phenomena, that's a biased approach. And that's not necessarily a good approach, especially not in the biological and the social sciences, but also not in complexity physics or condensed matter physics for that matter. So the fundamental criterion for trustworthiness is, as I said, robustness. And again, so he says there are robust phenomena, robust insights on all levels. Here's a good quote. Wimsatt says there should be more ways to interact with a spouse than with a quark. So this sort of idea of the theoretical physicist that quarks are in a way more real than your partner in a relationship is completely bizarre. You have many ways of affirming not just the existence, but the importance of your partner on your life. Okay, it's an empirical fact. And so the world we see, we live in, respond to, and act upon is too important, too central to our way of being to be dismissed right out of hand, like these sort of ontic fundamentalists would do. Okay, so robustness. How do I establish robust, phenomena, robust insights at different levels? So robustness means that things are robust if they are accessible. They could be detectable, measurable, derivable, definable, producible, you can make them, or the like, etc., 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 in a variety, and that is important, of independent ways. Okay, so a phenomenon, an insight, is robust when there are many independent ways of accessing them, and that is an access to reality. Okay, so if we make sure those ways are indeed independent, and we have to be very careful not to fool ourselves there. There are lots of failures and fallacies in this sort of a failure to assure that the ways we confirm them are independent. So robustness may apply to properties of objects, to relations, propositions. Propositional knowledge is included. It may apply to levels of organizations and, of course, to perspectives. So you can have a robust perspective. It does not require experimental measurement, okay? So it can just be purely observational, or you can make something, right? I mean, you can produce a phenomenon, for example, in engineering or synthetic biology, for example. But you can also rely, so you can rely on observation, you can rely on making and derivation. So it includes sort of the formal sciences. It's not restricted to the empirical sciences. This criterion does not give certainty. Nothing does. That's very important. There are no magic bullets in science, or anywhere else for that matter. We can never be certain. There is no certain knowledge. It's not possible, only robust knowledge, okay? But there is robust knowledge. There is knowledge we can trust more than other knowledge, okay? This is not relativism. Relativism is bad, especially in this sort of post-truth world we live in. So we can still, coming back to Hume, sort of our habits of believing in induction. There is no way you can logically prove that induction works. So that's the problem of induction, and the new riddle of induction. You cannot even, generally prove that something is more likely to be generalizable than others. But based on your experience, you can very well judge whether some, knowledge you have is robust or not. But you could always be wrong in that judgment as well. But you can make a judgment about how robust your knowledge is. It's very pragmatic, very empirical here, okay? It's not a logical way of ensuring the soundness of scientific knowledge. It's a pragmatic, practical way of ensuring the soundness of knowledge, which is based on the practice of doing science. It's very important. Okay, and this whole sort of, principled discussions about propositional knowledge, they're pretty useless in this regard because of all the problems we discussed in the previous lectures. That's very important. Another important aspect here is that what you're doing in science is you're never providing a perfect explanation. You're doing what is called sufficing. That's a term that Herbert Simon actually coined. It's a portmanteau of satisfying. Actually, this is satisficing. This is a typo. Satisfying and sufficing. Okay, so I apologize for the typo. And heuristics are algorithms that only work under certain circumstances. Okay, so what Wimsatt is saying here is that basically limited beings, this is a philosophy for limited beings, cannot hope to have a complete explanation of reality. We've had this argument before, and I'm going to come back to it. It's a completely irrational sort of idea that you could know the entire universe and understand it. And he calls this the myth of Laplacian omniscience, because Laplace had this demon that could, if he said you could measure all the sort of positions and velocity of all the particles in the universe at a given moment, you could not only, reconstruct its entire past, but also predict its whole future. But that Laplacian demon is an unattainable sort of ideal. It's something, it's a demon. The demon would have to be outside the actual universe to measure all those quantities, and would have to be, in fact, a god, an infinite being, not a finite being like us. Okay, so what we're doing instead, our scientific theories, serve to answer a given question or address a given problem. So this is what Herbert Simon calls satisfying. So satisfying, sufficing, not sufficing alone, satisfying. Okay, it's good enough, the good enough principle. Our scientific explanations are just good enough. They're not perfect, and that's fine, okay? Therefore, our scientific perspectives are not like algorithms that always yield the correct solutions, but more like heuristics, requiring much less effort, but only working under specific circumstances. Okay, so easy solutions, quick fixes, kludges that sort of work sometimes, but then they don't. And we need to find out when they don't and how they fail, okay? That's what science, doing actual science is. Limited beings doing science, good enough. The explanation needs to be good enough, not perfect. And you use heuristics that work in a certain domain, under certain circumstances, but not in others. Okay, so there are different approaches that are more or less generalizable, and that's okay. As our scientific knowledge evolves, Wimsatt says, some robust insights and theories become the basis of others. Okay, so basically, it's a view of science where we're constructing knowledge, we're building an edifice of scientific knowledge, and we're building insights, new insights based on others. This is Neurath's boat. We're in the boat, and we're sort of, fixing the boat as we go sailing along the sea of the unknown. Okay, and so as we do this, some perspective, so the more scientific perspectives depend on a robust insight theory, the more difficult it becomes to change it. So basically, some perspectives become entrenched, he calls this, okay? So foundational insights theories show generative entrenchments. The more you build on top of an insight, the more entrenched it is, and it's generative entrenchment because it allows you to build on it, okay? And you better hope that it's robust. It doesn't necessarily have to be. If it's not, it's a very bad thing, because everything that you build on top of it will come down. So generative entrenchment is not the same as robustness. You would hope that the entrenched sort of insights, the foundational insights in this building in this knowledge, edifice of knowledge, are robust, but you're never quite sure. Generative entrenchments is a feature not only of scientific insights and theories, but of central components of any adaptively evolving complex systems. So this is an important insight. Wimsatt sees our evolving knowledge as a complex adaptive system. It adapts, okay, to reality. And there is a selection for better knowledge. And so, but it's not perfect, okay? So it's an adaptive, knowledge is an adaptive complex system. And you have all these sort of central insights that are generatively entrenched. So for example, if you would take the theory of evolution out from biology, everything would crumble. Everything depends on the theory of evolution, more or less. And as Theodosius Dobzhansky once said, nothing makes sense except in the light of evolution in biology. So that's a very, very entrenched theory, and we hope it is robust. It is very robust, I can tell you, as far as theories go. So we're not 100% certain, but it's a very well-established theory. Okay, so how do we actually then proceed? And, you know, isn't this a mess? Isn't this a real problem? And here, this is one of the most beautiful ideas in Wimsatt's sort of philosophy. He calls this the metabolism of errors. The title of the chapter this is described in is called False Models as Means to Truer Theories. I love the word truer. So truth is a matter of degree here, and all of our models are false. They contain approximations, idealizations, abstractions. We'll come back to that when we talk about using models as tools in the next lecture, when we talk about the practice and the process of doing science. But what is important here is that these false models, they're useful to get better insights, to get more robust knowledge. Okay, this is a feature of our way of knowing, not a bug. If those models would be right, if they would be perfect, if they would represent a certain aspect of reality, you know, perfectly, they wouldn't be useful. Okay. George Box, statistician, famously said, you know, there are no models that are correct. All models are wrong, okay, but some of them are wrong in interesting ways, and that's exactly what this is about. Okay, this is a feature of our way of knowing, not a bug. This is why scientific knowledge is always tentative, and actually its shortcomings are important to make progress. Systematic bias and the errors of our theories produce contains information about how they fail, and that information is crucial. Analyzing them, metabolizing these errors, therefore, is our guide to new knowledge. Again, the more sort of perspectives you have, the better, because, you know, the more you can compare them, we'll come back to that in a second, and the more you can analyze by triangulating them. You can compare them and you can analyze their limitations much better. So more perspectives is a better thing. And also, and this is very important, this sort of gets us to Wimsatt's definition of what complexity is. He actually has two ways of looking at complexity. So one is what he calls descriptive complexity. And that's a very interesting notion. He says the more perspectives are valid, useful, interdependent, and the less they overlap, complement, the more complex the system we look at. So this is an idea of complexity that is based on the interaction of a researcher with the system they study. And this is extremely important, of course, in complexity science, in the life sciences and the social sciences, because we're dealing with amazingly complex systems. And it is crucially important that we maintain a lot of different perspectives, look at these systems with different perspectives. Only like this can we actually learn to systematize our errors, to put them in perspective, and to learn from them, to get better knowledge. Okay, so having multiple perspectives on a problem is a good thing. Okay, it's very important to state here that this is not just, again, silly relativism, or sort of what Bernstein once called flabby pluralism, that any sort of view in a system is okay. There are better views, to, you know, better ways to address a problem than others. Again, we can assess the trustworthiness of an approach, of a perspective. So there are better and worse ways, and you need to justify having multiple perspectives. Okay, not every system requires multiple perspectives. All of them need to be robust and trustworthy. Otherwise, it's just, you know, you multiply perspective gratuitously. And that is not the point either here. Okay, so it's not Occam's razor, but it's not the other extreme where you say anything goes. Any sort of perspective is valid. Okay, and that sort of goes into Wimsatt's second definition of complexity, which he calls interactional complexity, where he says the more interactions there are that intersect different perspectives, the more difficult it is to decompose the system. And he has this concept which he calls a causal thicket. So you have areas of reality like the atomic, the molecular, that are cleanly separated levels of organization. And then you have more complicated interactions between levels in the living domain, in the psychological, the social domain. And so sometimes it becomes completely impossible to sort of discern this hierarchical structure that Herbert Simon was talking about. It's becoming impossible to decompose the system. And when it's impossible to decompose the system, you have the highest level of interactional complexity, and this view of levels completely breaks down. And there are areas of reality that are like that. And in those areas like that often occur in the social sciences, for example, it's extremely difficult to generalize insights. Your insights become extremely context dependent. There's a really interesting discussion going on that was initiated by Yal Tarconi about the reproducibility crisis in psychology, where he says basically this is not so much about a failure to reproduce, but it's a failure to generalize insights in psychology, because these insights are so heavily context dependent, and that's just the way it is. So this is not mainly a crisis of reproducibility. That's also a crisis, but we need to distinguish that from a crisis of generalizability, that there are huge areas, important areas of reality that are just not amenable to general theory, okay? Nicholas Rescher, philosopher, has called this the surdity effect. So the more surd a fact is, the less generalizable its explanation. And some of these, a surd fact is one that cannot be explained by any general theory. That's an extreme case. And we cannot exclude that those facts exist. In fact, they very probably exist in the universe. So it is probably not, well, it's not a given that we can explain all the aspects of the universe by general laws. And so what are we left with here? Okay, so again, we're sort of left with, how is this still realism, right? How is this not just all social construction, all history dependent, all, you know, it's just your point of view? And this is where we maybe should get back to pragmatism. Okay, I told you at the very beginning of this lecture, you can be a radical pragmatist and saying, I don't care about realism. What I care about is whether a theory works or not. And in last lecture and this one, we said, okay, it's very important that something fits to its context. It addresses a certain problem. So here's William James, one of the fathers of pragmatism, and he says, the true is only the expedient in the way of our thinking. It's what works for our thinking. Just as the right is only the expedient in the way of our behaving. Okay, that's what a pragmatic definition of truth is. And so Ron Geary picks this up in his perspectivism, and he says a method is good to the extent that it tends to select hypotheses with desirable characteristics, such as agreement with data or wide applicability over hypotheses that lack these characteristics. I've shown you this quote before. I think it's very important. So there's a big sort of pragmatism in here, but it's not just that. It's not just what works. And so we can think about perspectival truth, this still being a realist sort of stance towards science, in the terms of philosopher Michela Massimi here. I really like her approach. She says, she sort of links it back to norms. Merton, think about Merton. So she talks about a normative realism, saying, you know, what we do as scientists, what we subscribe to is not just methodological naturalism, but also we subscribe to the idea that as scientists, we have to get things right. That is our ethic here, okay? And so that is our norm. That's what we aspire to. So she says, if we look at perspectival realism in this way, then you can express it in a nutshell as states of affairs about the world are perspective independent. What is happening in the world is not dependent on you in particular, okay? While our scientific knowledge claims about these states are always perspective dependent. So this is how she defines an objective reality out there, okay? States of affairs that are perspective independent. Shit happens, not in our control, not all of it at least. But our scientific knowledge is always bound to our perspective. So basically, perspectival truth is what tracks perspective independent states of affairs, but the conditions that make it true depend on the perspective. There's no way around this, okay? But we're still trying to track perspective independent state of affairs. And the only way you can do this, Massimi writes, is, well, you have to sort of distinguish between the context of use of a scientific theory and the context of assessment. That's very important. So the context of use, these are knowledge claims and they are sensitive, okay? to the context of use, the time, the person, they are, the claims are your background, the questions you ask, the explanations you want. While the context of assessment in science, knowledge claims that can be assessed across perspectives are getting things right. Okay, so we're now comparing perspectives. And this is what allows us to do the metabolism of error that Wimsatt is talking about. And this is what allows us to track the state of affairs of the perspective independent world. To get at perspectival truth, she says, we must compare perspectives. And so that's a disruptive strategy. To compare perspectives, we must first learn to step out of our own. And we can only do that collectively, because if you're on your own, you have your own perspective and that's it. So we need to compare views. And this is how we get progress in those areas of reality, once again, just to wrap this up, that are not clearly separated. Here's another beautiful picture from Bill Wimsatt's book, where he depicts the causal structure of the universe. And he says, okay, there are sort of, look at the bottom here, atomic levels, subatomic particles, really clearly separated levels, clear lines, and we can track those lines. But then you get into what he calls this biopsychological thicket, which is a real mess. Evolutionary biology, ecology, psychology, sociology, economics, really hard to do because the causal structures are not clearly separated into levels, and it's very difficult to sort of see how the perspectives we get relate to each other. What are robust perspectives? All of that becomes much more difficult here. Okay, so what we need is this sort of perspectival approach in order to be able to track the state of affairs, this sort of causal thicket out there of reality that happens independent of our mind. We can track it by using this heavily multi-perspectival approach, by comparing perspective. And this is how we make progress in science. Okay, so this is the central point of this entire course. So this lecture is going to be a little longer. I'm sorry for this, but here we go. So what this means is that in a world like the one we live in, depicted in this beautiful diagram by Wimsatt here, we can have generalized laws and theories only in those areas where these levels of organization are clearly separated. But it does not mean that those are privileged sort of levels and we should reduce everything, bottom out to those levels to explain what's happening up here on the right-hand side. It's just we need a different approach. Again, perspectival approaches. We need specific perspectives, representational models of specific phenomena that are happening up here. And we need to sort of take serious the phenomena that happen at these higher levels. And these are two very different ways of explaining in science. So on the left is the classical physics way of the covering law sort of way of explanation, that you subsume the phenomena that you have under a general law. Okay, and it's been quite successful in physics, although we still don't have a unification of quantum theory and general relativity. So even those very general theories, they only apply in their respective domains. So they're basically very broad models, okay, as well. And what we have in the life sciences and the social sciences are much more specific models of specific phenomena that are much more context dependent, much less generalizable. And so what we need here are much more particulate sort of specific perspectives that are encoded in specific models that are not necessarily generalizable. And that is not a problem. That is the adequate way of going about those specific areas of reality where we cannot have these very general theories. Okay, so different ways of explaining, both of them completely valid in their own domains. But you do not need laws, general laws, and it's probably futile to search for them if you're a biologist or a social scientist, but rather focus on accurate models and how you use those models as tools. We'll come back to that in the next lecture. So think about, maybe to wrap this up, as perspectives in terms of maps. So our theories, our scientific theories, they provide perspectives that give us certain features of an environment. Here you see a map of Vienna, a pretty detailed map. Is it a useful map? It has all kinds of things on it. I find it very sort of difficult to read. Here is another, a tourist map of the center of Vienna. If you're a tourist and you want to do sightseeing in the first district, you get all the different sites at one glance, you know, the Hofburg here, St. Stephen's Cathedral, everything. immediately recognizable. This map is much better for your particular purpose in this regard. You want to go sightseeing, okay? Pedestrian zones are indicated, or you get a public transport map. Beautiful, simplified, completely distorted, idealized, you know, the distances, the angles are all wrong, but it allows you to connect very quickly anywhere in the city. And so maps and models are just sort of formalized perspectives. They have a lot in common. Both are objects, not statements. So we move away, very far away from this idea of knowledge, propositional knowledge as true propositions. Okay, maps are physical, models are abstract, but neither of them can be true or false. They're similar or applicable to certain sections of reality, applicable especially. So a very pragmatic way of going about it. Maps and models are partial. We know that. They're only useful when we have a specific feature selection. They are of limited accuracy. You don't want to use the sort of public transport map to walk around and find something, you know, on foot, but also similar to the real world feature they represent. But it's very good. You will find your way using public transport very easily. Maps and models are interest relatives, therefore, okay? Map makers and scientists' conventions are very important. So we need to look at the practice and the social circumstances of how we do science if we want to understand science. There is just no way around it. So the objectivist realist approach of just having some sort of general view does not work. And science is not completely abstracted from the sort of environment that it's done in, but it is still a special way of gaining knowledge, which is not just like any other way of knowing. And this brings us back to the central sort of point of we need to look at science as a process. How is science actually done? We need to look not how a map is a representation of reality, how it corresponds to reality, but we need to look at the activity of representing. What are we trying to achieve? A shift of focus from the products of science, these so-called objective facts, to the process based on scientific practice. And this is what will happen in the next few lectures. We'll shift gears and look from perspectivism to the sort of process and activity of doing science. I hope you will tune in again, and I hope you like this lecture a bit longer than usual, but this sort of, you know, working out of perspectivism, which is not relativism, which is not objectivist realism. It is a compromise, a middle way. It is a better way of representing science in the 21st century. Thank you for listening, and I hope to see you again next time. Goodbye now.